Okay, so let's do a few more examples of the inflection points and concavity from the second derivative. All right, so here we have a function f of x. Again, we're going to get to the second derivative after the first. The first derivative would be 24x squared plus 4x cubed. Second derivative, 48x plus 8x. I'm sorry, 12x squared, or in other words, that would be, take out 12, take out a 12x, 4 plus x, and there's our second derivative. All right, then we look to see where the second derivative is 0 or where the second derivative is undefined. It's 0 when x is 0 or when x is -4, and there aren't any places where the second derivative is undefined. So I go to my number line. All right, and I would put -4 and 0. Start plugging in numbers. So I'm going to plug in, say, -5. If you plug that in to the second derivative, you're going to get a positive number. If I plug in, say, -2, I'm going to get a negative in there. And if I plug in, say, 2, I'm going to get a positive over there, giving me the function is concave up there, concave down there, and concave up there. Hence, we do have changes in concavity, so I do get an inflection point at -4 something and an inflection point at 0 something. Again, I have to go back to my original function and plug those values in. So if I plug in -4 into that, run that through, and you should get -56. If I plug in 0, that's easy. That's just the 200 there. So -4, -56, and 0, 200. Okay, and then I will summarize. Concave up on -infinity to -4 and 0, infinity. Concave down on -infinity to 0, and inflection points at -4, -56, and 0, 200. Okay, so let's move on to the next one here. X minus 3, x to the 1/3. All right, start with the first derivative. 1 minus x to the -2/3. Then the second derivative. All right, 0, so then positive 2/3 x to the -5/3, or in other words, 2 over 3x to the 5/3. All right, so there's our second derivative. Ask our usual questions. When is the second derivative 0? When is the second derivative undefined? 0. Well, it's never 0. Look at this the second derivative. It has 2 in the numerator. So it can never be 0. But it is undefined at 0, and in particular, the original function was defined at 0. So that's the point that we want to consider there as a second derivative being 0, undefined point. Okay, so that's the only point that's going to go on our second derivative chart here. So now if we plug some numbers in, all right, notice what we're doing over here. The only thing that's going to affect the sign is this x to the 5/3. So that's a cube root then to the 5th power. So negatives will stay negative and positives will stay positive. So that means it's going to be negative in that region, positive in that region. Hence f concave down here, and f concave up here. And we do have a change in concavity there. So this is an inflection point at 0 something, and I can pretty simply see that if I go back to my original function, if I plug 0 in there, I will get 0. So it is at 0, 0. So summarizing, concave up on 0 to infinity, concave down on negative infinity to 0, and the inflection point at 0, 0. All right, let's do one more here. 2x to the 4th minus 8x plus 3. First derivative, 8x cubed minus 8. Second derivative would be 24x squared. Okay, so now I want to look again. When is the second derivative 0? When is the second derivative undefined? All right, when is it 0? Well, x equals 0, undefined, none. So I go to my chart. All I have is the 0 that we found. Okay, so look at my second derivative. Now notice it's 24x squared. That's always going to be positive, so it's positive before and positive after, which gives us an interesting situation here. We do not have a change in concavity. In other words, f is concave up here, and it's also concave up there. So we do not have a change in concavity. 0 is not an inflection point. So if I want to summarize here, I have concave up on negative infinity to 0 and 0 infinity. I shouldn't include 0 because the second derivative is 0 there. And I don't have it concave down anywhere, and I don't have any inflection points. So that's all we get there. So that you can have a 0 of the second derivative where there is not a change of concavity, and hence not an inflection point.